So, a couple of things. Number one, this unit that we're in right now is the last thing that we're going to do before the semester exam. And it's not covered on the semester exam. This is true for the friends at East End and North Central and wherever else teenagers are watching this video. The BC semester exam covers the first 5 units. Unit 1, limits, continuity, asymptotes, all those things. Unit 2, the derivative as a function, f, f prime, f double prime kinds of things. Unit 3, this is the love unit, all the derivative rules. Unit 4, this is where things start to fall apart for some of the friends. Applications of the derivative, L'Hopital, mean value theorem, all the things. Unit 5, definite integral. You have your unit packets for all 5 of these things because no one was foolish enough to throw them away or lose them. They're somewhere in this pile of stuff. Looks like a 6th grader's backpack threw up. Okay. This weekend, you need to start getting your house ready. You need to start getting your life in order for the BC semester exam. Okay? 2 dates that I want you to know about. One of them is next Wednesday. Next Wednesday, I will be staying after school for tutorials from 1:15 to 2:30. Plan on being here. Plan on being here to work, study, make flashcards, whatever you need to do. The other time that I'm going to be staying after school is next Friday from 4 to 6. Mr. Link and I are just going to have like a calculus jam session. AB students, BC students, we're going to do stuff. Lots and lots and lots of stuff. There's only one additional unit on your exam that's different from the AB students. So whatever they're studying is good studying for you all, and you can help them out. And, you know, earn generosity of spirit and love and things like that if you care about those things. All right, I also want to remind David and Lewis and Polymon that you guys are meeting the AP folks tomorrow during lunch because the 3 of you said you were...
Right. I forgot about it too.
I know. That's why when it was like the 3 of you, I'm like, oh God. Room 36. Yeah. I will not come find you and get you over there. I've already sent your names to Miss Bauer, and I'll tell you, if you are not there, she will find ways to hurt you.
Oh, and she's in charge of the entire education.
Yeah, you'll never graduate from any school anywhere. All right, so let's talk about where we are in Unit 6. Lots of integration stuff happening. Oh my gosh. Oh my gosh, there are things. Here come the lifesavers. Integral of x to the n dx. Who's got it for me? Get your hands up in the air. Otherwise, instead of throwing lifesavers, I'll throw heavier objects. David.
Is 1 over n plus 1.
Yeah.
Times a to n plus 1.
I don't think you're done yet.
Oh, plus e.
Plus Charlie. Right, power rule. Add 1 to the power, divide by the new power. Now I'm curious, how does that help you with something like this? Somebody else. How do you integrate the square root of x? Uh-oh, only one person? Carmen, what would you do?
You could treat the square root of x as x with the power of 1/2.
Right, this is really a power rule problem. Square root of x is x to the 1/2. And so what's the antiderivative of x to the 1/2? What does the power rule tell you to do? The power rule said add 1 to the power and divide by the new power. So usually in my old man brain I think, what's the new power? Add. No. When you add 1 to the power, 1/2 plus 1 is 3/2. There, 2/3 comes into play when you think 1 divided by 3/2. This is really where it's 2/3 plus c. Okay. Integral of 1 over x dx. Celeste is ready for that one.
Natural log of the absolute value of x plus c.
Natural log of the absolute value of x plus c. If you don't have the absolute value bars there, it's wrong. All right, you want to get in soon. Antiderivative sine of x. How long?
Negative cos.
Negative cos or positive cos?
Negative cos.
Negative cos or positive cos? Negative cos.
Negative cos of x plus
plus c. All the quiet people want to get in real fast. The integral of e to the 4x with respect to x. Don't tell her the answer. All right.
1 over 4 e to the 4
Plus c, love it. Yeah, I couldn't reach that far all the time. All right, antiderivative of 1 over x squared plus 1.
10.
Now I'm being mean. You had your opportunity to get in earlier. Now I'm being mean. 1 over x squared plus 1. This must be here for a reason. We haven't talked about it yet. But is there any, the question you want to ask is there anything that you know that when you take the derivative, Andrew, you get 1 over x squared plus 1? Arctan. More specific though. Arctan of x plus Charlie. Nice. All right, then we might see something like the antiderivative of secant squared of x dx. Allez.
Tangent of x plus c.
Tangent of x plus c. Nice. Now, y'all cannot catch for anything. Okay, what about the antiderivative of k where k is a constant? A constant like 4, like 3, like pi. You're like, no. Okay, Lewis. It's going to be kx plus c. Love it. Carmen has no faith in our ability to throw and catch together. Antiderivative cosine 3x with respect to x. Shut up, Helmo. Sine of 3x.
Sine of 3x times.
Remember, you're dancing backwards. I agree with you, sine of 3x. And then 1/3. Okay, plus c. Okay. Okay. I think that one may have actually been my fault. All right. Everybody mostly okay. You just have to have some of these things memorized. You just got to get them down. Okay, good. Now it's time for the push. So in the middle of the table, we've got the reflection document, we've got the test corrections, and you've got the homework that you did. All right, now it's time for the push. We can do indefinite integrals. You guys have done a great job with indefinite integrals. I want to come back to the world of the definite integral. Definite integrals, for those of you that don't remember, look something like this. The difference between a definite integral and an indefinite integral. Tell somebody near you, what is the difference? What's the difference between a definite integral and an indefinite integral?
A definite integral has a
Okay, I heard definite integrals have limits of integration, indefinite integrals don't. With a definite integral, the question that I'm asking you is a question about... With a definite integral, what's the question? It's an area question, right? You're going to give me a number for your answer. With an indefinite integral, it's a function kind of question. So today we're going to focus our attention on definite integrals. So this first one, the definite integral of stuff that I can't read, from -1 to 2, would be asking you what's the area bounded by the curve in the x-axis from -1 to 2. And options for evaluating this include, type it into the calculator. Does everyone remember how to do this on the calculator? Okay, convince me and you that you actually know how to do this on the calculator. I want you to evaluate both of these definite integrals on the calculator, and then we're going to do it the fun way. The way Stephen's been doing for a long time.
Yeah.
Stephen, we're catching up to you today. It's time to do some more Googling. Evaluate the definite integral in both of these cases. David, what are you getting for a definite integral?
The first one?
Yep.
I got 9.
Okay, David says that the definite integral on the first one is 9.
Yeah.
Anybody else?
No.
Second one?
15.750.
15.750.
Yeah.
Gisella? Okay, it's charging. Friends over here, are we okay? First one has an answer of 9. Second one has an answer of 15.75. Put the calculator away. We're not going to use the calculator ever again. It's time to upgrade your skills. Andrew's like, but no. It's my second brain.
It's my first one.
In some cases, it's the first brain. I know. Okay. The secret to evaluating definite integrals lies in something called the fundamental theorem of calculus. The fundamental theorem of calculus we know and we love, and we use it all the time. The fundamental theorem of calculus, you may remember it as f of b equals the fundamental theorem of calculus.
F of A.
F of a plus this definite integral
A to B.
from a to b
Prime.
f prime of x dx. Okay, we're going to repeat this as the final value equals the initial value plus the total change. Final value equals the initial value plus the total change. Alright, everybody's okay with fundamental theorem of calculus? We use this all the time. We use it with position, we use it with rate functions, we do all the time, all the time. Some textbooks, though, they use a different notation. Instead of little f and f prime, what they say is big F standing for antiderivative. The value of the antiderivative at b is equal to the value of the antiderivative at a plus the integral from a to b of the derivative of the antiderivative. The derivative of the antiderivative, what should happen there? They like cancel each other out and you're just back to little f. This is the key. What I'm going to ask you to do, what we're going to be doing with these problems is figuring out what is the value of a definite integral. If you think about the fundamental theorem of calculus and rewriting it, what the fundamental theorem of calculus says is find the antiderivative, evaluate it at b, subtract from that the antiderivative evaluated at a. Everybody kind of okay with this? Let's just do it, and you're going to be like, oh my god, I get it now. Alright, let's give it a whirl. So, problem number 1 is clearly a definite integral, and you guys have already told me that the answer is supposed to be, was it 9?
Yeah.
Let's go get that 9. Yay! Let's go get the 9. The start is, what's the antiderivative? What's the antiderivative of 3x squared minus 2x plus 1? You're frozen for a little while. Antiderivative of 3x squared minus 2x plus 1. Another way to ask that question is, what function do we know of that has this as the derivative? Where does 3x squared come from?
X cubed.
X cubed minus, where does 2x come from? X squared plus the
X.
plus x. Now I know you guys would say then, plus Charlie. This is the antiderivative. I've got a new notation for you. Or really a recycled notation. I'm going to use that bar. That means evaluated at. I'm going to evaluate this function at -1 and at 2. What the notation tells you to do is plug in the 2 into the antiderivative. 2 cubed minus 2 squared plus 2 plus c minus, plug in the -1, -1 cubed minus -1 squared plus -1 plus c. I found the antiderivative. This notation is what we're going to use to say evaluate the antiderivative at -1 and at 2, your lower limit and your upper limit. The fundamental theorem of calculus says evaluate the antiderivative at the top limit, evaluate the limit antiderivative at the bottom limit, subtract. So let's do it. 2 cubed is 8, minus 2 squared, what are we at now? That's 4. Plus 2 is at 6 plus c. Minus these parentheses over here, so important. -1 cubed is -1. Minus -1 squared, I think we're at -2 now. plus a negative 1 is that negative 3? Right, just evaluating stuff there. 6 plus c minus negative 3 plus c. Six plus c minus negative 3 plus c. That should be 9. Right? And that 9, hopefully not a surprise. Not a surprise for anybody that the answer is 9. Your calculator told you the answer just a little bit ago. The new piece for us right now with these definite integrals is to evaluate a definite integral, you find the antiderivative. You evaluate the antiderivative at the top value, you evaluate the antiderivative at the bottom, you subtract. Done. Questions? Everybody kind of okay? All right, let's do one more together. Why don't you have a strategy conversation with somebody near you? You see this problem on the streets, what are you going to do?
Fight it.
I'm going to run.
Carmen, Stephen, Lewis, Andrew.
Such a good question. Hold that thought for just a little bit. Now, if I was in a class filled with some AB students, there would be some struggle bus stuff happening right now. Right, folks would be like, wait, but I don't know what the antiderivative of 1 over the cubed root of x is. This isn't in the list. I haven't memorized it. But you guys know what to do. What are we going to do? It's really a power rule problem. This guy here is a power rule problem. So give me some algebra first. Rather than 1 over the cubed root of x, are we okay going straight to x to the negative 1/3 power? Plus the cubed root of x, that's x to the 1/3 power. I'm going to be ruthless. Polymon, I want to make sure this came through loud and clear. Ruthless with notation here. I still need to see the integral. I still need to see that you're doing a definite integral from negative 1 to 8, and I still want to see that dx. Oh, it's positive 1 to 8, thank you. I need the antiderivative of x to the negative 1/3. Antiderivative of x to the negative 1/3. Think about the power rule. What does the power rule tell you to do?
X to the 2/3.
Right? Add 1 to the power. Divide by that new power. So the antiderivative of x to the negative 1/3 is x to the 2/3. Divide by 2/3. Is the same thing as multiplying by 3/2. Plus the antiderivative of x to the 1/3. Add 1 to the power is x to the 4/3. Divide by that new power is the same as multiplying by 3/4. Plus Charlie from 1 to 8. Is everybody okay with the antiderivative piece? Okay, and then from here, Polymon, what are we going to do?
From here, we're just going to plug in 8 to the equation.
Okay, so 3/2 times 8 to the 2/3 plus 3/4 times 8 to the 4/3 plus c is just some constant, so I don't plug 8 in there. Minus, I want to see those big parentheses because that minus has to impact everything that comes after it. 3/2 times 1 to the 2/3 plus 3/4 times 1 to the 4/3 plus c. Now let's have some conversation here. Free response part of the test?
Leave it like that.
Leave it alone. Carmen, why are we going to leave it alone?
I don't know what's the cube root of 8.
Right, I mean, are we going to be able to figure out 8 to the 2/3 power? Yes, you all know how to find 8 to the 2/3 power. But if it's the free response part of the test, the rule is don't simplify. Don't simplify. However, I want to make sure I'm really preparing you for the multiple choice part of the test, so we are going to simplify. Okay, there's also something else that could be done to make your life a little bit easier here, and it has to do with the C's.
They're going to cancel out.
They're going to cancel out, right? They're going to cancel out because in this case it's c, in this case it's minus c. They cancel out. Hey, guess what? They canceled out back over here, right? Which means that they would have canceled out back over here. Which means most calculus teachers, when they're teaching their students how to evaluate a definite integral, they say don't even bother with the plus c at this point. Just find the antiderivative. Don't worry about the plus c part because we know it's going to cancel. Plug in, subtract, get out of there. So let's finish this off. Yes, I want you to simplify this one as much as you can. Okay, 8 to the 2/3 power. 8 to the 2/3 power means find the cubed root of 8. 2. And then square it. 4 plus 3/4. 8 to the 4/3 power. Cubed root of 8. 2 raised to the 4th power. 16 minus 3/2. 1 to the 2/3 power. Cubed root of 1. 1. 1 squared? 1. What a waste of time. Okay. Plus 3/4. Let's see if you guys figured it out. 1 to the 4/3 power?
1.
Oh my god, 1 to the 4/3 power is 3/4.
1.
I just want to throw up. Okay. It's 1 to the 4/3 power is just 1. Simplify a little bit more. 3/2 times 4 is 6. 3. What? 12? What?
12 and then divided by 2.
3/2 times 4 is 12 divided by 2, which is 6. Okay. The next one, were you talking about the next one?
Yes.
12, okay. So you're having a future conversation. Okay, 3/2 times 1 is 3/2. That's 3/4. 6 plus 12, what is that? 18 minus common denominator here of 4. 6/4, 3/4 makes that 9/4. I'm not going to give that to you in the multiple choice. I want you to simplify further. 18 minus 9 over 4.
Just 2.20.
Myra has a really good guess. Her gut says it's 15.75. Okay, if you get a common denominator here of 4ths, 18 is 72 over 4. Minus 9 over 4 is 63 over 4. What a beautiful answer. Anybody have a better way to write 63 over 4? 15.75. It is exactly what you're getting through the calculator, except now you have the skills to do this on your own. Everybody mostly okay? Alright, so I want to give you guys some time to practice. Really, the way that you're going to get better at integration is you're going to integrate a whole bunch of stuff. Tonight's homework, in case I forget to say it, is assignment number 90. It's just a bunch of integration questions. These are going to be so much fun. Oh my god, look! Trig,
Yay.
exponentials, multiplication, division. Oh my, it just couldn't get any better. It just couldn't get any better. You guys have the next 12 minutes or so. Your goal is to complete as many of these as you can using your newfound skills. If you want to evaluate this on your calculator first, figure out what the right number value is supposed to be, then do the integration to make sure that you're actually moving in the right direction, totally okay. Everybody all right? All right, I'm going to put 12 minutes on the clock. Every now and again, I'm just going to pick somebody's paper, put it under the document camera.
I think I'm going to have to.
That's why this thing's so thick. Stephen, we are filming, right?
Yes, we are.
Okay, just checking.
No, we're not.
just going to say David's handwriting is getting very good these days. You almost can't tell the difference from David's handwriting to Myra's handwriting. They're almost the same. David, I'm so proud of your handwriting.
Thank you.
All right. All right, so integral from 0 to pi over 2 sine theta plus cosine 2 theta. My friend over here says negative cosine theta plus sine 2 theta over 2. And you may not be able to see it well enough, but does anybody see anything wrong? Any concerns that they have? I see something. And I'm wondering if anybody else can see it. It could just be that it's too light. Celeste, what do you see?
He forgot the bar.
Yeah, you want to be careful. This notation here says find the antiderivative. And the antiderivative of sine theta is what you found over here, negative cosine theta. The antiderivative of cosine 2 theta is what you found over here, sine 2 theta over 2. The problem is that the notation that's being used says go find the antiderivative again. What you want is to say this is the antiderivative. Now let me evaluate from 0 to pi over 2. Plug in the pi over 2 next. Negative cosine pi over 2 plus sine 2 times pi over 2 divided by 2 minus negative cosine of 0 plus sine 2 times 0 over 2. I love it. I love it. Free response. Stop. Get out of there. But let's assume multiple choice. You do need to know that the cosine of pi over 2 is 0. And that means that 2 times pi over 2, let's see, this is pi, sine of pi is 0, minus cosine of 0 is 1, so that's a negative 1 here. Sine of 0 is going to be 0. Is positive on the answer you get in the calculator? Everybody okay? How many of you guys honestly came up with one through your integration skills? Nice, keep going. David, nice job.
Thank you.
All along, you doing okay? Oh, who cares? Next one, antiderivative of e to the 2x should be 1/2 e to the 2x. Antiderivative of e to the negative 2x is negative 1/2 e to the negative 2x. Evaluate from negative 1 to 1. I'll tell you, if I see something like this on the quiz tomorrow, first point earned already. You found the antiderivative? Great. Your notation says it's time to evaluate. Yes, David, you were totally listening. You were like, wait, he said quiz tomorrow. We'll loop back around. So let's plug in the 1, 1/2 e squared, minus 1/2 e to the negative 2. All that minus 1/2 e to the negative 2 minus 1/2 e squared. Are all the friends in the room okay getting here? Good. Now, here's the thing. I'm going to be mean. Multiple choice, this won't show up as an answer. I will not put this as a multiple choice answer. You need to know how to simplify. Anybody see any simplification that can happen?
Oh, snap.
Lewis, what do you say?
Would it be 0 because you like subtract all the,
No.
or like 1? Because it's like 1/2 e to the negative 2 minus 1/2 e to the negative.
Hold on. You said 1/2 e to the negative 2 minus 1/2 e to the negative 2.
I mean-
Those would cancel. However, this isn't 1/2 e to the negative 2. It's the negative of 1/2 e to the negative 2. So you've got negative 1/2 e to the 2 minus 1/2 e to the negative 2. That's just going to be negative 1 e to the negative 2. That takes care of those two. 1/2 e squared minus negative 1/2 e squared is going to be 1 e squared. Which I would probably more likely write this as e squared minus e to the negative 2 Or if I really want to be strange, e squared minus 1 over e squared. Lewis, so you're okay with the things not canceling?
Sure.
Okay, that sounds like no. Okay, we'll talk. Keep going.
Yeah, when you put in -1 to the first one, why did you put positive 2 in the first one? It was
Oh, that's really
Right, so you plug in the 1. 1/2 e
Oh,
squared
okay.
minus 1/2 e to the negative 2.
I see what it is.
Okay.
I put them on the wrong side.
So we don't
Ah.
know what E.
So the order of the subtraction
Yeah, that's all
matters,
I
right?
did, yeah.
Top minus bottom. Hi, friend.
No, listen.
Okay. Getting here, you're good. Love it, love it. So now it's just a matter of simple.
So this is just.
With e squared, the only thing that I'm going to be able to work with, combined with the e squared, is another e squared. I think, were you looking at the e squared and this e to the negative 2? And the problem is they have different exponents, so they're not terms. Okay.
Over the square root of x cubed.
Leah, do you have any advice for all the friends at home who are trying to figure out how to evaluate that definite integral?
You can change the square root of x to x to the power of 1/2.
Okay, and that makes life better. Why?
Then you could distribute it.
Right, now makes me want to throw my calculator on the ground too. I'm so excited. Oh my God, square root of x is x and a half, and now I can distribute it. You can do whatever algebra in the integrand that you want as long as it's legal stuff. Legal stuff only. So now I've got x to the 3/2 minus x to the 1/2 dx. Power rule. Power rule. Antiderivative of x to the 3/2 is x to the 5/2 times 2/5 minus x to the 3/2 times 2/3. I hope everybody's okay. Evaluate from 0 to 16. I have got to see that evaluation bar. It is non-negotiable for me. Now we plug in the 16. We've got 2/5 times 16 to the 5/2 minus 2/3 times 16 to the 3/2 minus, plug in 0. 2/5 times 0 to the 5/2. 0. Minus 2/3, 0 to the 3/2. 0. So your final answer is going to be whatever 2/5 times 16 to the 5/2 minus 2/3, 16 to the 3/2. I mean, I'm just showing off now, but square root of 16 is 4. 4 to the 5th is 1024. Times 2/5 is 2048 over 5. 16 to the 3/2, square root of 16 is 4. 4 cubed is 64 times 2/3, 128 over 3. Common denominator is going to be something in terms of 15. Multiply that by 3, multiply that by 5, 6,144 minus 640. I think that's 5,504. And if you divide that, you're going to get something like 42.667. No.
128.
366.93.
Sounds good to me. Okay, here's the good news. I would be very comfortable with you all stopping here. I am not interested in all the fractions, all the fraction business happening. Everybody okay? Really, it's just a matter of practice. Tomorrow we are going to have a quiz, a short 15-minute sticker challenge kind of experience quiz. Okay? The first sticker is going to be earned by your knowledge of basic integration formulas. Do you know that the antiderivative of e to the 2x is? Antiderivative of e to the 2x is?
E to the 2x divided by 2.
E to the 2x divided by 2 plus Charlie. Do you know the antiderivative of 1 over x is? Natural log, the opposite of that. Right, all those just like pop, 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 pop. Plus Charlie all the time. And then maybe 3 or 4 problems involving indefinite integrals. That's tomorrow's quiz. Short, skills-based, earn your stickers, life is going to be good. Everybody good? All right, time. Pardon?
It's gonna be on the quiz?
No, definite integrals will not be on the quiz yet. Okay? All right, so here's how we're going to split the group. We've got 12 minutes left. I want to give you guys an opportunity. Those of you that liked having the derivative foldable, we're going to make an integration foldable. Those of you that just, you're like, I'm not into that kind of stuff, that's fine. Just stay off camera. All right.
Is it gonna be worth the grade again?
No. Okay, Stephen, if you could stop filming, because we're going to create a video.